I hope you're ready with some more very insightful content from some more experts from around the world. We're starting off the second part of our day by discussing from mines to batteries, alternative material sourcing in the upstream. So please applaud our wonderful panelists for this section. Ines Kolmsee, General Partner of Matterwave Ventures. Moshiel Biton, CEO and co-founder of Addionics. Eloisa de Castro, CEO of Enerpoly. Marc, Bouchet, Investment Associate at TDK Ventures, and moderated by fantastic Robina von Stein, an investor at Contrarian Ventures. Welcome to our stage. A round of applause, please, for the wonderful panelists.
Yeah, amazing. Man, woman. Great to have you all here, and amazing to discuss with you guys also a very important topic today. As we talk about energy transition, it's always a material transition. And actually, we at Contrarian Ventures spent quite a lot of time to think about, what does it mean? Because we talk about also a lot a geopolitical challenge here, right? Like scarcity of minerals, access to minerals, who are basically almost 90% or more controlled by China. And China has built up this dominance in the whole supply chain, from mining to the extraction, but also the refinery part. And now, obviously, Europe and the US tries to build up a more domestic supply chain. So very exciting to discuss with you, 4 experts in the field, also a little bit the different technologies and solutions we have to diversify this challenge we have in the market to basically build up our scalable solution and sustainable solution for batteries. So very happy to have you all 4 here. So I give you also a quick intro about you, and then we dive into the topic. And in the end, I will also have a little bit time left for the audience to ask some questions because I think it's a big chance to discuss also with everybody. So we have Marc from TDK Ventures, and you recently moved from US to London, and maybe you give quick intro about yourself, just 1 sentence, and then we can have a short intro about all the panelists.
Perfect, I'll keep it short. Thanks, Robina. My name is Marc, I'm with TDK Ventures. We're a deep tech corporate venture capital fund. I used to be based in San Francisco. Now I'm in London. We have 2 main pillars for investment with our latest funds, 2 funds, each $150 million. Generally, we focus on energy transition technologies, mostly hardware, hard tech, and then we also look at industrial and digital transformation technologies as well. We are excited to have multiple investments in the world of the battery materials supply chain, which I'm sure I'll draw on for this conversation. And really glad to be here. Thank you, Robina.
Moshiel, do you want to go next? Like one of our innovators building a component, a new technology design. So maybe you can tell a bit about yourself.
Thank you, and thanks for the invitation. So I'm Moshiel, the CEO and co-founder at Addionics. Addionics developing the next generation of current collector for batteries, both copper and aluminum. We're replacing the traditional metal foil to make batteries actually more dense and low cost. Already working with most of the, I would say, world-leading companies in the supply chain. And excited to be here. Thank you.
Thank you. Ines, investor at Matterwaves, and also board of Umicore for more than 12 years, I think. So great to have you.
So I'm Ines from Matterwave Ventures. I'm one of the partners there. I joined Matterwave only 2 years ago. Before that, I had a career on C-level in different process and energy companies. So my last role was in a stainless steel producer. Before that, I was also in the energy space. So I was the CTO of a utility company. And we were already starting to invest in batteries at the time. That's 10 years ago. But I also have had and still have a number of external board mandates, and the one that's most relevant for today is Umicore, where I'm not there anymore, on the board for 12 years. So I'm going to share a bit more experience, I think, later on that.
And now to you, Eloisa.
Yes. I'm Eloisa. I am the CEO of Enerpoly, and Enerpoly is a Swedish battery innovator. We are based in Stockholm, and we innovate in zinc-ion batteries. Zinc-ion batteries are particularly interesting for Europe because Europe has a tremendous amount of zinc mining. And the batteries that we work on are for stationary energy storage, medium to long duration. It's more sustainable, more safe, and can compete on cost with LFP from China.
Great to have you all here. And quick intro on myself. I'm Robina. I'm an investor at Contrarian Ventures, early stage investor fund. I'm mostly covering German market and had a discussion with my colleague yesterday about German founders, German investors who are not so funny, apparently. So I was really thinking this night to start this panel with a joke, but I obviously couldn't find one, so I hope you guys help me on that. So, yeah, but let's start a little bit, and I want to start with you, Ines, talk a little bit about the alternatives, the answers to this, how to build up and diversify a more sustainable and scalable and also cost competitive in the long run battery supply chain from the upstream side. Like as response, we do have innovation in recycling, and we talked about this for a while. We have innovation in new technologies, something what you're building on, and obviously like alternative extraction technologies or areas to explore, right? Like deep mining, deep sea mining, and so on. So I would like to understand a little bit also from your learnings at Umicore, 12 years, decade of understanding where the market and also the geopolitical stress and also the price fluctuation of these commodities were probably a little bit different than now, how the industry has adapted and changed and look at these different answers, and what are the strategies behind it?
Yeah, I don't know whether everyone knows Umicore. Umicore is a Belgian company that used to be actually the mining activities of Belgium in the Congo, in Africa. That was divested 25 years ago, and the company focused only on precious metals and the different industrial usages for it. And when I joined 13 years ago, the whole rechargeable battery material space was totally nascent. They started to have contracts with Apple for the first versions of the iPhone, and then later iPad, which was already much more battery material that was needed, etc. But at that time, it was a complete Asian supply chain. So, and Asian in this context was Japanese and Korean. It was only later that the Chinese came into the game. Also, when they started to build up their EV supply chain, their EV industry, and then they very quickly became industrially so strong that they were able to bring down cost in a way that the Japanese and the Koreans weren't able to do. And this is how they basically took over that Asian supply chain to a large extent. And at that time, Umicore was buying those materials from Asia and was quite happy with it. Yeah, so it wasn't the time of thinking about like geopolitical topics, etc. It was the cheapest way of doing it. It was the time of globalization at the end of the day, and this has changed only really when the first European and later American OEMs came into the game of EVs. And started to say, well, we wouldn't mind having some kind of battery supply chain here in Europe. And then with more geopolitical tensions came the realization, well, we need to invest now. Yeah, and that whole industry, and I think that's something that we as a VC need to remind ourselves of, is absolutely nascent in Europe and in the US, while it's pretty established standard in Asia. Yeah, so we are looking at old technologies in a way, but a new place where we are trying to establish that. And that's going to be a tough one. It's not easy. Yeah, and we're going to need all the help that we can from novel technologies, not so much from a venture capital standpoint, not so much in like investing in a complete supply chain, but saying, okay, how can I make this supply chain cheaper? How can I make the production cheaper? Because it's going to be a big scale, low margin business. Yeah, so that's not something that usually VCs like to invest in. Therefore, I think you really, from a VC perspective, need to choose the areas where you can help the big guys that will be able to bring up the scale to become more efficient, to become cheaper. And so this is my view on that supply chain. It's not an easy case for VC. And this is when I look at companies, this is the angle that I look from.
Yeah, I mean, I 100% agree. Marc, maybe on your learning there, because what Ines said, I think we have the challenge in Europe especially. We don't really, we don't have the infrastructure there, but you and TDK has invested in actually ones like Ascot Element, a big recycling pioneer who's now moving to Europe. Also, you have invested in several just extraction technologies, and obviously, like I think also one sodium state battery technology.
Yep.
So you have invested in, let's say, these 3 different answers. All US-based companies, I think?
No.
Oh, no, 2? Yeah, okay.
Yeah.
So tell us a little bit about it, like from your venture, like what Ines said, I think are good points, important points.
Definitely happy to, and I think reflect all of Ines's comments around competing on economics is incredibly difficult in the materials space fundamentally. I mean, when we're talking about commodities, there's sometimes only so much you can do. I think when I look at TDK Ventures investment strategy, we could say, or approach to innovations in the battery space and battery materials space generally, we do force ourselves to look for companies that have a very deep unit economic advantage thanks to the novel technology, novel process innovation that they're bringing to market. I think that is borne out in our investments in this space. On the recycling side, you mentioned Ascend Elements. Their direct-to-cathode recycling process takes out the steps of going back to metal salts and then resynthesizing a PCAM, a cathode precursor, or even synthesizing the cathode material itself. So you get pretty immense economic improvements from just precipitating out the material that you want, that is a high-value specialty chemical. That's one good example where, of course, there's competition in the battery recycling space, but they were very strategic in understanding where their supply would come from. They were very confident in developing an IP portfolio and protecting their innovation and showing it at a meaningful enough scale to then convince customers to start signing offtake contracts. And once you have that entire end-to-end ecosystem, Ascend can now develop projects. They can go for DOE funding. They can really scale up the business, and they have defensibility ultimately in the long term, even if there are competitors, even if it is a commodity or more and more commoditized material space, because they have very strong fundamental unit economics from their technology. So I think that's one good example, and that would be replicated across how we looked at sodium ion with Peak, how we looked at existing lithium ion battery manufacturing with AM batteries, which is a dry electrode coating process. I would say actually with Moshiel and Addionics, there's similar benefits where when you start rethinking those core innovations that have huge unit economic impacts to the way a battery is manufactured today, you can get away with a venture investment, but that's not every startup. So we do need to be honest with ourselves that it has to go through a pretty tight filter on, as investors, are we spending time on the techno-economic model? Are we spending time on actually understanding the consumer demand and willingness to pay, and customer demand? And that's how we try and replicate it within our fund. So I could point to Peak. I could say that the insight there is that if you go to a sodium material supply chain, maybe initially the batteries are not that competitive from a cost perspective with LFP, but certainly in the long run, we have to believe that a more localized supply chain for sodium cathode material to North America is going to be competitive with a China-owned lithium supply chain. So those are the kinds of questions we're asking ourselves. And then to a point that Ines made earlier, we want to work with really strong operators as well, because the technology is just one part of it. We know that Peak has the operational skill of bringing up gigascale battery manufacturing in multiple geographies, and that's what the team is good at. It's almost not a technology question. It comes time to building the gigafactory. They're the ones who have done it and can do it again. So that's where some of our confidence comes from as well.
Yeah, no, I mean, I agree. I think it starts always fishing out or finding the technology which has unit economic advantage, but then it converts to operation, and are you able to scale and build up? So Eloisa, I think maybe to you now, I think you try to build really a full stack battery manufacturer in Europe with a new technology or different technology. So how do you, I mean, also to what Marc just said, I think you built in the short, medium term, short, medium term battery storage space, right? Like
Yes.
you're competing with lithium ion battery, which are the costs of these materials just said went down so extremely that it's like the mainstream technology to use now in the market. So how do you think about winning in the market and what you need, especially in Europe, to build up a manufacturer there? How do you
Well, there are a lot of things right, that go into winning in a market, and I mean maybe we can ask me again after we've won.
Yes, I will do this. No worries.
How I think about it is that there are really two parts. One is know your customer, and two is know yourself. In the first part, and know your customer, you have to understand throughout this entire scaling journey, who are the customers that are willing to take a look and knowledgeable enough to take a look at a new technology now, and can be ready to adopt it when it's at small scale. And there are already customers for battery technologies that are looking specifically at non-lithium, right? And their priorities are, sustainability, safety, and when you're looking at the very large-scale customers, and I'm talking about utilities, right? And that's a large majority of the market. Right now, the battery energy storage that's deployed is about 80% utilities. And utilities need to look at this at scale. And so at scale, that's when the cost matters a lot more. So you need to have something that, for the customers, is competitive enough when it is small scale, and then is able to reach that unit economics at the large scale as well. And so our approach to that part of the equation is really focusing first on the materials, because materials for batteries are 60 to 80%.
Yeah, that's true.
For our bill of materials, we're able to reduce that by about 50%. Just by using very abundant materials, and we have a lot of zinc in Europe. And then on top of that, as Ines mentioned, and also strengthened by Marc, the operational excellence absolutely has to be there. Now, we do have a new type of battery manufacturing. So what is really needed is having that right balance of achieving the excellence in operations to have high yield and a high throughput, and being able to do that in the small scale, as well as being able to plan for the industrialization of this at large scale, is incredibly important.
And how do you see Europe? I mean, you're American, right? Like you grew up.
Yes, I am.
So, I mean, you mentioned let's say, geo advantage by having a lot of zinc in Europe, which probably is one reason why you choose Europe also to build a company. But how did you decide to where to found a company, and why Europe versus US, who has probably some form of, if you talk about capital at least, or also part of infrastructure advantage?
There is a significant infrastructure advantage. To be honest, we started the company in Sweden because the technical co-founders did the research in Sweden. So the technology was born in Stockholm University. It's based on the PhD research of our CTO and co-founder. And when it comes to making the decision to grow this company in Europe, there is the significant advantage that the technology that we're working with, it's a rechargeable zinc ion technology, And it's made with the same materials as what has already been used in the non-rechargeable zinc AA battery, non-rechargeable industry. And so we have this, not only do we have a lot of zinc available in Europe, but it's already an established supply chain. So this is something that we're able to build off of. And because these types of batteries have been around for more than 50 years, we also have an existing recycling infrastructure to build off of. I mean, I know we're talking about the upstream, but if you're thinking about cost and the way that customers think about cost, then the ability to have inexpensive ways of being able to either dispose or recycle their batteries is really important, because that goes into the entire levelized cost of storage equation, or the eventual project cost equation. And then being able to also have a jump start on circularity is a big advantage for these upcoming regulations in the batteries.
Yeah, this is a good point, and I think there in Europe we have actually a stronger regulatory force or framework, which now actually makes also as an element in a lot of recycling companies moving to Europe. So I think I agree on that point that probably Europe will be a hub also for a lot in the recycling space, but also in circular material innovations in the space. Maybe now to Moshiel, because it's always difficult to manage that everybody can speak. I love actually what you're doing. Maybe you can tell it a little bit more about your company, and what is really fascinating is that you're chemistry agnostic, which, as we a little bit discussed so far, we have a very fragmented market now on a lot of different chemistries. So really, maybe you can share a little bit how you enable the battery chemistries to be more efficient.
Thank you. Yeah, it's totally agree. There is no any, I would say, a crystal ball that we can say which chemistry is going to win this race.
Exactly.
And a lot of competition and fragmented market. And we really want to bet on the battery race, but not on specific cores. So we are building a platform that can serve any type of chemistry, any type of process. Marc mentioned like new type of process, dry process, wet process. We don't know even which format is going to win. We see how different battery makers, automotive OEMs betting on different formats, cylindrical, prismatic, pouch. And it's still, I would say, a big question. So when we started the company, we really wanted to make sure that we will serve the whole battery market. And we realized there is a component that was overlooked, the current collector. Current collector, it's a 2D metal foil, similar to the foil that we have in our kitchen. And the structure of this foil hasn't changed since the invention of the lithium-ion battery. Believe it or not, before the lithium-ion batteries, for instance, nickel metal hydride, companies use nickel foams to use current collector. But when lithium-ion batteries became commodity, the most important part is the cost, and nothing was able to compete with the conventional foil. Mm-hmm. It's good enough. It's make the job. There is no any need to replace it with any alternative off the shelf that will be much more expensive. And the reason that we are very attractive is the fact that we can actually produce smart 3D metal structure at lower cost than producing foils today. And that's what makes us, I would say, quite attractive. And if we are going to have a closer look on copper, and we are in, I would say, mines to batteries session. So copper in the electrification era is becoming like the new gold. In electric vehicles, we have 3 times more copper than conventional vehicles. And, at the end, batteries are everywhere, and we just need to believe that there are going to be more electrification, if it's robot, data centers, AI, etc. So batteries are needed in order for energy storage, and it doesn't matter I would say, performance, but we need batteries. And we need more copper. So you can look at Addionics as I would say, copper mine, but in a reverse way. So we are actually taking a scrap of copper, dissolving it, and produce the three structures from this recycled copper. So circular economy, and you'll be surprised, but for instance, in the US, there are mountains of copper that actually shipped outside the US to do the refining and the processing, and then getting back the final product. And it's not make sense from a circular economy, I would say, zero footprint approach that everyone wants to take. So we see that as an opportunity, advantage. And as the result, we can reduce the amount of copper and aluminum in the battery up to 60%, which is huge. And it translates to cost reduction. But even if cost reduction is not, I would say, enough, you need to have also performance benefit. And when you have the full package of performance benefit, cost reduction, and supporting the supply chain, this is becoming very attractive, and this is allow us to work with different type of clients around the globe, world-leading automotive companies, battery cell companies in Japan, in Europe, in the US. And you need, in this market, to make sure that there is a pull and push. This is super important, to have it from the end user, the buyer, and the cell maker. And when you create this coalition, it will allow you to scale up, because there is a chicken and egg. I will show you the product. I brought it with me, a product. So thanks for encouraging me to bring the product.
It was Ines' idea, actually.
Yeah. So
I like physical stuff.
Yeah.
And I think
So you can see a little bit more, getting a better understanding what we are talking about, actually.
yeah, so you can see it's full porous. You can see me through that. I don't know if the camera can do that. And the idea is to create, like, I would say, structures that will load more active material. We can put more dense battery and the same volume. So reducing, I would say, there are lots of real estate that is not utilized. All the, I would say, notion of nanotechnology, a lot of space at the bottom. And this is what we're doing, and the advantage of making that in a low-cost process. So, yeah, that's, I think, the main impact of our technology.
And Moshiel, if you work very closely, obviously, with the automotive companies and cell manufacturers. And what is in their radar? What is in their head? What are the main things they're stressed out, and how do they want to kind of optimize on it? Do you see a lot on, okay, they build new technologies, new chemistries, and then use your, let's say, platform approach to optimize on that, or securing? I mean, we see automotive companies trying to own the upstream part going into mines, right, or the recycling part downstream. So we see like they try to also own big portion of the infrastructure, and plus also investing in new technology. So, I mean, you have also worked over several years now with the automotive companies or cell manufacturers. What were your learnings there, and where do they spend most of the time and money on?
Yeah, so definitely there is urgency from the battery and mainly from the automotive side to adapt and to be innovative in this market. It's not a secret, but most of the batteries are coming from China, and they are controlling the market. And especially with the decoupling that we see from China and the US, there is the urgency of also building onshore stable supply chain in the US. And you won't be able to compete with China by just copy-paste. You need to bring innovation. So those companies looking to have any competitive advantage to be able to compete. But at the end of the day, they are also very conservative. So cycles are very long. There are lots of, I would say, qualifications working with those companies. So I think the sweet spot is to be able to bring technology that will make a big impact, but the change will be small. And that's, I would say, the art, how to keep the balance between not to make a big change, to make sure that you have a drop-in solution. So for instance, our process or our product integrating into existing production line without any change of the tools. So we can use existing infrastructure, brownfield, but also be suitable for greenfield technology. So to be able to be flexible and dynamic. The automotive market wants to bet on technologies that will give them the ability to be dynamic and flexible, because they also don't know which technology is going to win. So if you have a technology that will help them to reduce costs, because they are worried, they are losing money on electric vehicles. Part maybe Tesla, BYD, that not losing as all the others. So they want to have technologies that will reduce costs, but at the same time, they don't want to bet on technology that is not going to be in the finish line.
Yeah. I think if I can maybe build off of, I think something you mentioned earlier, which is you are building a platform technology. I think this gets to something that I'm trying to build out from the early stage investment perspective, where how much should we be considering NMC and LFP for EV applications as a foregone conclusion? Is this really a space to still be investing from the early stage VC perspective, where we want to be finding the platforms of the future, the materials of the future? And I think that it extends even to, if we push the question, NMC, LFP fundamentally developed for EVs somewhat. The EV game might also be won by China. We see BYD coming into Europe. We see them starting to expand into the US. We know their prices are cheaper than Tesla. There's going to be a huge fight coming on. For me, this begs the question of where do we go looking for that end application that's going to pull the rest of the periodic table into the battery world for their demand and their use case, right? So I think about Europe. I think of commercial and industrial facilities that face huge energy price hedging questions. Should they be looking for a chemistry that's more like zinc ion, that can be something that they put behind their meter that enables them to balance their energy demands? Should we be looking in the should we be looking in the US, where there's at least 300 gigawatt hours of utility scale renewable firming storage demand today? That's what we're looking at with peak energy. It is this goes into the notion of the fit-for-purpose battery chemistry, right? Why wowould we force fit LFP and NMC into use cases where we have an entirely new opportunity to build demand, to build an entire supply chain for a chemistry, for materials platforms, for manufacturing capacity that is for domestic demand, built domestically with innovations that allow us to compete with that cost model to China, where maybe we just say China's won EVs and batteries and they won LFP and NMC. Like, my early stage mindset is like, I want to go find the next zinc battery. I want to go find the next chemistry platform, material platform, right? Obviously considering economics, but those. Let's focus on the new demand sources to pull in the rest of the alternative material supply chain. I think it has to be that way.
Well, if we need, if we need 300 gigawatt hours for capacity firming, did you know that with the zinc mines in Europe, we can, if we really wanted to, build 370 gigawatt hours of batteries made of zinc?
Those are maybe the matches that we should be looking at when we talk about where is the alternative material sourcing supply chain and where does it apply, right? Because if it's just to make EV batteries, I'm not sure,
And what are the enablers? I mean, what do we need actually to, I think it's a good question you posed, like fit for purpose, but I think it's we talking about, but we need political pushes, I think. We need the industry to be ready and the infrastructure, what you said before, right? Also, you mentioned this, you also like integrating into existing infrastructure. So I think, yes, I agree, we need the demand push, but I think what else do we need there? Open question to you, Ines.
Bankability.
Bankability.
Yeah, I think
exactly.
That's a main reason why a lot of the battery applications today are not fit for purpose. You're using chemistries that are not the best for this particular application. This is because right now, banks or financing institutions have become very comfortable with NMC batteries and LFP. But that's it. So once someone wants to invest in that space, like private equity, growth investors, etc., they need the bankability. And as long as you don't have that, there will be no mass deployment.
And I would almost put this question back on Eloisa, is how are you thinking of getting to proving bankability, that someone who wants to underwrite your technology for a 20-year asset lifetime, like that they can get that sort of confidence? Like, how are you thinking of that? Because we ask founders a lot. Like, we're trying to understand.
It's a really good question, because if you're thinking about bankability, especially for a company like a battery manufacturer, right? You need to have bankability for the operations of the company, right? So that the company can even make batteries that that are at a realistically much lower TRL level than all of these other mature technologies. And then you also have to think about the bankability of the infrastructure that you're building, right? I mean, there has been a lot more talk about first of a kind financing. There are more options for getting grant funding. It's something that Enerpoly has been able to do. We have been able to secure grants from the European Commission through the EIC Accelerator. We've been able to secure grants through the Swedish Energy Agency. And this is going a long way toward being able to reach a 100 megawatt hour per year capacity of manufacturing. But there is still that other side that needs to be bankable. So what the way that we think about our customers is that there are customers that are really knowledgeable about, what does it really take to succeed with batteries. It's an absolute pleasure to talk with them because they know how to assess technology. And so at the early stage, you have to work with the innovators, right? They have to be innovators. They have to know how to assess battery technology. They have to know that there are other battery technologies and other applications that maybe lithium ion is not ideal for, even though 90% of what's been deployed in a battery energy storage recently has been lithium ion. And you have to work with them with the knowledge that to be able to build a factory, right now we're building a mega factory, but we need to build a gigafactory in the future, right? And the whole process to do that is at least 5 years. So you need to work with the people that know what they want in 5 to 10 years. It's incredibly difficult, but they do exist.
And hopefully they won't change. They will not leave their job within these 5 years.
Won't get turnover.
Or teach their successors.
Yeah, it makes me think of Moshiel, something that we think about a lot on this question of, are we the right CVC innovator investor for a new battery technology? And are we also around the table with other investors who have that capacity? It's the notion of sometimes even like the investor customer or the investor development partner, right? That model seems to work, once in a while. And I see it in the mining space and the material supply chain, a lot of the mining companies being that investor, but also initial demand source for that startup solution, or at least willing to trial it at the pilot scale to start helping that company get towards those bankability metrics.
No, I agree, actually. And I think CVCs actually play a super important role, more important than maybe 10 years ago in the climate tech transition, in the climate tech investment, as we more as a financial investor probably are not the right fit for a pure, unique, novel chemistry in battery, just from the skill set, but also the risk we would take, as we couldn't really underwrite probably the client demand you just described, right? Especially in the pre-seed seed stage. So I think this is a very important capital stack we need there in the industry. Additionally to what you, I think, also managed to secure a lot of government funding. I think you were able to close some grants, right? Maybe you can talk a little bit about your capital stack, also what you have built and how you think of building this now, also raising your Series A, and what is the locks, critical unlocks you need in order to close your Series A?
It's a very big question.
We are here to discuss big questions.
No, but it's the founder's journey is something that I think within the battery space is continuing to evolve. But one thing that is going to remain true is that you have to continuously monitor what the opportunities are around you, and think in advance of what does this mean for the way that we manage our scale now and later. Mm-hmm. And the difficulty is making sure that the technology, the manufacturing, the team, the commercial side, the commercial development, that all of these things align so that they can move and accomplish your strategy together. And we've had to actually, pivot a few times. So when we first started the company, we were thinking that with this promising technology that we had proven at laboratory scale and had several industrial partners that we worked on with, we thought that maybe we can innovate on this technology, manufacture with a similar method as a lithium-ion battery manufacturing, and then license this technology to battery manufacturers that are, that want to adopt a similar equipment, a similar process. And, very early on, after having conversations with several customers, not just customers, but also different stakeholders in the industry, mainly the battery system integrators that would then, want to source battery cells from, who our direct customers would be. We realized that the level of collaboration that is needed with them when they're evaluating and potentially putting, a new battery technology as a component in their products, like that kind of support really needed to come from the battery technology innovator, and it needed to be pretty thorough support. Right? You have to have joint projects together to be able to commercialize the technology. And it became very clear that the licensing method was not really something that we could do with such a new technology. Maybe if we're making a very incremental change to lithium ion, then it's something that you could do. But for a very novel zinc ion battery technology, it really wasn't the case. And so, because the business model changed, then the way that we had to approach all of the different, parts of the business also had to change. One thing did remain the same, though, and that was that excellence in procurement and being able to use materials that were not only cost effective, but that we could see in the future is something that we would be able to scale up with. That was something that always remained the same. And so, with the previous business model and the current business model, we have always been working with suppliers and planning for the future and scale up, making sure that this is something that we can achieve in the supply chain.
Oh, that's super interesting. I saw that we only have 3.5 minutes left, and I wanted to open a little bit for the audience. And there's a question, right? So maybe you have one. So.
The lithium market with the nickel technology, because you already have all the bases covered with the grants. All you need is the economic development conversation. Can the country of Sweden benefit from a competitive resource for new battery technology against lithium? And they'll be very excited. The state of Texas has made a decision, even though they don't do green hydrogen, they made a decision to be green hydrogen. So now you have them popping up everywhere. So the money and the infrastructure is there because they made a decision. So this is a conversation with economic development as well as the economic development as well as the government. And ask that question, because everybody wants to be competitive. You have to speak the language that they want to hear. You're in the weeds with the technology, but there's a simple conversation you need to have with economic development because they want to bring revenue to their country.
Yeah. Well, I think economic development will want to bring revenue and also great jobs. So it's always something to consider, right?
There was one more question here.
Yeah.
Yeah, hello. First of all, thank you very much. Super insightful discussion and information. My name is Jens Raffelsieper. I'm Senior Director for Clean Energy Associates. We're a technical advisory company doing a lot of ESG traceability work for many years already regarding based on UFLPA, clean energies, polysilicon. And we are doing also, for many, many years, we are doing also now a lot of traceability, chain of conduct, ESG work regarding to batteries. Talking about bankabilities, talking about establishing new factories in Sweden and Eloisa, maybe. How are you treating this challenge also, because in Europe it's coming more and more of controlling the supply chain, controlling the ESG, and especially when it comes to materials like nickel, like lithium, like copper. How are you treating this? How are you treating these challenges? And what would be your solutions? And yeah, also happy to help if you need any support from our side. So happy to have you answer.
Well, from an ESG perspective, working with zinc batteries and the materials that we work with is already a tremendous advantage when it comes to having a low carbon footprint. So we have done work to analyze what the carbon footprint of our manufacturing will be with jointly with external consultants, and we are expecting that our factory in Europe will be one of the top 3 lowest carbon footprint, and Europe has the best in terms of sustainability when it comes to battery manufacturing. So how am I thinking about it? I mean, it is a top priority. When you really look at the things that you can control, you look at the supply chain and being able to source sustainably there. So working with different suppliers and evaluating their sustainability, making sure that you're up to date on what kinds of certifications there might be for different types of materials. With zinc, there is the International Zinc Association is developing something called the Zinc Marc. It's something that they have done in collaboration with other commodity organizations. I believe copper has done a copper mark. And that's one thing that you can look at from sourcing. From the energy consumption perspective, it is always ideal to be close to clean energy. That's a big contributor to what to the LCA analysis. I didn't have to say analysis, A meant analysis. And there are other things having to do with operations that we will be looking into. We're at an early stage, so this is something that we're going to do in the next step, taking a look at transportation and logistics and what that means in terms of sustainability for us. So those are the most immediate ways that we're thinking about it. But I'm happy to have a conversation later if you have other things in mind.
In short, you need to hire a very good lobby company.
This is a very pragmatic approach, but I think in general, this question is something that the whole industry is only waking up to right now. Yeah, cobalt has been a bit more in people's mind because of child labor, which is something that no one wants. Yeah, but nickel mining in Indonesia is coming now to people's attention. So, in a way, this is driving innovation. Yeah, because you look much more at recycling, so urban mining. You're looking at first of all, eliminating cobalt from the battery chemistries, and now nickel is also a bit in the spotlight. And in a way, for the innovators, this is an interesting development, which makes more local, more sustainable options possible and financeable and bankable, etc.
But I think this also comes full circle to the point on regulatory influence and local economic development. If we're choosing to prioritize the climate alongside with scaling up our industries for battery manufacturing, it does effectively, and we assign incentives to that or structures to reward or penalize whether or not you meet those metrics on carbon emissions, on sustainable sourcing. We are picking potential winners and losers. We are making room for new innovators. I think we do force the question of battery manufacturing in Europe has to be fundamentally lower carbon emissions, otherwise it's just not acceptable. So I think creates room for startups to continue innovating, for sure.
Yeah, I agree. Yeah, so we are actually running out of time. So thank you so much for all joining our panel. As a closing, I would like that everybody gives like the investors one statement about what excites you most within this value chain at the moment. What technology are you most excited to see so that maybe people can reach out to you? And from the innovators here, I would like to hear, what do you think it needs to really build a sustainable, scalable supply chain for better domestic battery supply chain, basically? So these are my last questions, and then we wrap it up. So last statement for everybody.
Maybe a very spicy one. I think there's a ton of demand for energy storage technologies. It's not going anywhere. We need it to firm the grid. I think actually we should be looking at transmission distribution, which would be potentially hand in hand and or something that if we're thinking about investing in energy storage, we should consider if T&D gets better, do we still need all that energy storage? Do we build more flexible, more interoperable, tradable energy markets for renewables?
Which is an interesting difference between Europe and the US. Yeah, Europe will need less storage because we have better transmission systems to start with.
So what is your
there is a number of dirty secrets in the battery value chain, like sulfates, which are created when you do recycling, but also when you produce PCAMs. And there is not many solutions how to treat them. So if anyone has a solution on the topic, I'm very happy to talk to them.
Nice, good.
I think for me, the most exciting area is the inactive component in the batteries. They are less focused, overlooked. They are not the chemistry that everyone is working on. I think there are more opportunities in the electrolytes, binders, current collector, separator. That's very exciting, and also material saving. I think from scale-up production, we feel there is a plateau, and the material saving, it will be the next way to reduce cost.
Yeah, makes sense. And now to you.
From my perspective, what we need for a sustainable European supply chain is to capitalize on our strengths. And I'm really looking forward to developing internally and then seeing also other ways to develop. In this industry that is used to having a lot of the cost optimization done outside, I would like to see really innovations in engineering and cost optimization in production, and also in the supply chain and experience and operations after the battery, between the manufacturing of the batteries and all the way to the end user.
Yeah, I think that's a long way to go in Europe.
Yeah.
But yeah, so it's closing, and thank you so much all for joining our panel. So,
Thank you.
and thank you.